Finally, I would like to introduce one of the technically quite important law, because in photochemistry, to understand the excited state, at first we need to most likely need to measure the transmittance, meaning the absorbance of the molecules or solutions or samples. So this is one of the most general way to understand, to know the property of photochemical properties. And first, you will probably have experienced to measure the transmittance of the sample in a cuvette cell. So you put a solution, your sample solution in the cell, and then put in a spectrometer to measure the light absorption. So meaning when the light is illuminated and you measure the transmittance of light. So transmittance is defined by the I over I0, and depending on the wavelengths. And absorbance is defined like this: A is minus log 10t equal, if you put this definition here, the minus log I over I0, which is equal to epsilon C L, where the epsilon is called the molar absorptivity. And this is one of the important properties of molecules. And C is the concentration, and L is the thickness of the cell or sample. But due to some traditional reason, in this equation, there are many kind of not common unit is used. For example, in the molar absorptivity, we use a centimeter instead of meter, and also the thickness is also we use a centimeter, because most likely we use 1 centimeter cubit, and then the sample thickness is given by 1 centimeter. There are some other issues too. So let's think about how to obtain this equation. Before going into this, this law is called Lambert-Beer's law, right? And let's obtain this equation and from the scratch. So please think like this: if you have very thin layer of your sample with the thickness of dx, and when the input light intensity is I, and then the light intensity is changed to I plus di, and from this relation you can solve the differential equation to obtain this equation. So please stop a video for a while and then make a equation. Okay, let's think about this. Now, we need to understand the di over dx. So the light intensity, how much light intensity changed during the propagation in dx is, so which property do you think it is proportional to? And Of course, you can easily imagine that this should be proportional to C concentration. Okay. And also, we need to understand that this is proportional to the original intensity of I. So if the original I is larger, the change is also larger. And the other thing is epsilon prime, which is proportional constant somehow. And I just mentioned this one is epsilon prime, not epsilon. So I will give you the reason later on. And also the light intensity, because most likely light is absorbed, this is a decreasing function. So you need to have minus. So by solving this equation, simply move the I to the left side and minus epsilon dash epsilon prime, and then concentration is and dx. Okay. So the range of the integration, you can think like initially light intensity is I0. And in this case, the thickness of X is 0. And then I is changed to I. And at this point, the thickness of the cell is L. Okay. And you can solve this equation. So L logarithmic I over I of 0 and equal and minus epsilon prime C L. So you can notice that you have to be very careful about this one. So from the answer obtained from the scratch, that's a natural logarithmic. Of course, this is from the differential equation. But keep in mind, this is common logarithmic, meaning log 10, right? So you need to change the logarithmic to log 10. So what you have to do is, this is log 10 I over I0 log interchange the base 10 E equal to 2.30 log 10 I0. Right. Then this from this log 10 as I equal minus epsilon 2.30 CL. Right, now it's clear what I mentioned, as this one is changed to epsilon. So because in most of the case, we are not interested in the power of E, but power of 10, right? Because we human quite easily notice that when the order is changed. So we would like to think about the order change of 10, right? So that's why we use a common logarithmic. Then this is used. So that's why this initial epsilon prime, which is from the original mathematical equation, is not corresponding to the molar absorptivity. So molar absorptivity is converted and then included in this term. That's this. So this equation is quite a practical equation for when we use. And I'd like to mention that this property you have to check in papers or the literature, and somehow you have to understand this is a large light absorption or small light absorption. So I'll just mention that if the epsilon is 10 to the 4 to the 10 to the 5, that's a kind of big. So strong light absorption, maybe strong light absorption. And for example, 10 to the 2, that's a weak light absorption, meaning like N-pi state, it's like this small absorption, but in many cases, it's important. So with that, in this lecture 3, we studied the excited state and the relevant phenomena of the excited states.